Hello students, in the last class in IUPAC system of nomenclature we studied the 5 different terms. You remember that is a primary prefix, secondary prefix, root word, primary suffix and secondary suffix. Okay, so today try to understand the different rules used in IUPAC system of nomenclature. Okay, so it is not just the words and rules. If you know it is sufficient, you have to know the application part of that. Okay, the first rule, to start with a very simple one, that is a longest chain rule. Okay, so now you will ask, what is this longest chain rule stands for? Now basically you consider there is a carbon chain like this. Okay, simple example I try to tell you here. If 3 carbon atoms forms a straight chain like this, it is normally, what is the root word, students? Prop. Okay, between the carbon atom there is a single bond, it becomes a propane. Same carbon atom becomes a chain like this, then it becomes a butane. So here in this case there is no concept like a longest chain or a shortest chain, because the parent chain has got the same number of carbon atoms. Okay, now the difference what I make is, instead of writing a straight chain like this, suppose if I show a branch like this. Okay, now look at this, there is a 5 carbon atoms in the straight chain and there are 2 carbon atoms forming a branch in the carbon chain or in the parent alkane chain. Okay, so now what will be the root word for this? Okay, so I told you earlier we have to count the number of carbon atoms to get the root word. If you number from here 1, 2, 3, 4, 5, or if you number from right to left, that is same 5. Okay, whether you have to consider this. That means only the question what I am asking you now is it a pentane or not? Okay, now as far as the first rule here, longest chain you have to consider. Okay, so you may start numbering from here, and once you reach till here, then you extend the numbering in this direction, not the straight there. Okay, that means usually you consider, suppose if I start numbering from here, this is the first carbon atom, this is the second carbon atom, this is the third carbon atom, fourth carbon atom, fifth carbon atom and sixth carbon atom. So root word of this becomes a hex, not pent. Okay, so simplest thing you have to understand. Now many of you will ask a question, what about this carbon atom then? If you numbered in this direction or this direction, what will happen to the remaining 1 carbon atom? That will consider as a substituent there. Okay, so it is very easy. You must understand in a n number of examples, you must number the carbon chain in such a way that will get a maximum number of carbon atoms. Okay, I will give you one more example, then you become clear with the longest chain rule, how it is applicable. Maybe the carbon chain looks like this. There may be some substituents here. Okay, there may be some substituents here. Now in this case, if you just consider this main chain, the 1, 2, 3, 4, 5, pent, you are wrong. Okay, so you have to number it in such a way that we get a maximum number of carbon atoms. So how you get the maximum number of carbon atoms? So looking at the chain, you will understand. We'll start from here. 1, this is the second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom. Instead of continuing there, we say this is the 6th one, 7th one and 8th one. So the root word of that becomes the oct. Instead of just 5 carbon atoms we consider in the straight chain. Okay, so it may be a straight chain or a branched chain, but you have to understand when the longest chain rule plays an important role. When it has got any significance, only when there is a branch. I told you earlier, if there is a straight chain, you number it from left to right or right to left, there is no difference, you will get the same number of carbon atoms. But whenever you can see a branches like this, okay, the different substituents attached to the carbon chain, if it is having again the alkyl groups only, then you must number it in such a way that will get a maximum number of carbon atoms. Are you clear? So the rule number 1 is simple, longest chain rule, where we consider the carbon chain in such a way, we number the carbon atoms in the carbon chain in such a way that will get a maximum number of carbon atoms. Are you clear? So I'm just telling you a rule, and after completing these rules, we'll come back to the examples. There you have to understand, yes, how to number it and how to proceed with the nomenclature of an organic compound in IUPAC system. Are you clear? I think this is simplest one, longest chain rule. Now moving on to the second one, that is a lowest sum rule. Okay, now we will ask, what is this lowest sum rule? Simple. in this case, okay, generally the longest chain rule you understood. We'll go ahead with the one more simplest example, how the lowest sum rule is applicable. Okay, as the name itself says, what do you mean by lowest sum? Okay, so let me take up the first example. Here I will erase this numbering. Okay, this is a carbon skeleton present maybe. Okay, I will write one more carbon atom here. Okay, let me write here some other substituent, maybe CH3 group, or it may be some other substituent present. Okay, or I'll write a halogen, maybe Cl. Now rest all I will not fill, because you know that all hydrogen only. Okay, in this case, when you want to number it, okay, so difference what you have to make out is, in the numbering of this carbon chain, if you number it from left to right, okay, so again you can understand, it may be the ethyl group, it may be the CH3, same, the number of carbon atoms remains the same in both the directions. So if you number it from left to right, this is the first carbon atom, second one, third one, fourth one, fifth one, and sixth one. Okay, so the root word remains hex. Suppose if you number it from right to left, try to understand, students. This is the first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, and fifth carbon atom, and last sixth carbon atom. Many of you are thinking now, longest chain rule is not applicable there, because if you number it from left to right or right to left, you are getting the same number of carbon atoms, 6 carbon atoms only. Root word remains hex. Okay, now what is the significance of the second rule, that is the lowest sum rule? Now, even though it can be numbered from left to right and right to left, we will get the same number of carbon atoms. Only one is correct, only one is accurate among these two. Which is that? How to decide? Now, as far as the second rule, the lowest sum rule, try to understand the sum of positions of that substituents in both the directions. Are you getting what I am telling? Okay, I'll repeat. See the position of the substituents. Yava carbon atom ಗೆ substituent attach ಆಗಿದೆ, ಆ position ಅನ್ನು note ಮಾಡ್ಕೊಳ್ಳಿ. Add the positions where you get the lowest sum. That is the right way of numbering. Means if I number it from left to right, the first substituent, this is a substituent. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? This is a substituent. It is present on the fourth carbon atom. The one more substituent present on the fifth carbon atom. So I will add those two numbers. Got it? Fourth carbon atom having one substituent, fifth carbon atom having another substituent. So I'll add 4 plus 5. Okay. So when it is 4 plus 5, this becomes sum 9. Artha aita? And suppose if I number it from right to left, look at the positions now. Substituents present there only, but we are numbering it in the opposite direction. So the first substituent present on the second carbon atom, so I'll write 2, that is a position of one of the substituents, and the next substituent present on the third carbon atom, so I will add that 2 plus 3, that becomes equal to 5. Okay, so now try to understand, students, what do you mean by lowest sum? We can number this carbon chain in both the directions, left to right or right to left, but which is the accurate one? Which is correct according to IUPAC system of nomenclature? In which direction? When you number the carbon chain, the substituents positions, once you get it, you add that, the sum where comes the lowest, that should be the right way. So if you number it from left to right, it was the fourth and fifth position, so I added those two positions, I got a sum as 9. When I number it from right to left, second and third carbon atom having a substituents, so when I added those positions, I got a sum as 5. And among 9 and 5, which is the lowest sum? It is 5. So the numbering is right way from right to left. So left to right numbering is wrong. Okay, in this case we can't number it from left to right, we have to number it from right to left only. Okay, so any two substituents, I am not asking about a methyl group or halogen, something like that. Any two substituent comes, like generally what you can write an example. Suppose if there is a carbon chain like this, okay, suppose I'll write something X here, I will write Y. Are you getting what I'm telling? X and Y, that are the two different substituents. Now looking at this, can you tell me, is it numbered from left to right or right to left? is it numbered from left to right or right to left? How you number it? Again, lowest sum rule when you want to apply. See, in this case, the longest chain rule is not applicable. Longest chain rule is not applicable because you consider in any way the number of carbon atoms remains same. Okay, so we have to consider the parent alkane chain in such a way that we'll get a maximum number of carbon atoms in longest chain rule. That is already over. We are discussing about lowest sum rule now. The only question is it numbered from left to right or right to left? Okay, so how you number now? This is the first carbon atom, second carbon atom, third one, fourth one, fifth one and sixth one when you number it from left to right. So what are the positions? Second and fourth. Clear? Second and fourth positions having the substituent. So 2 plus 4, it is 6 when you number it from left to right. Okay, suppose if you number it from right to left, in this direction if you number it, it is a first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom and sixth carbon atom. Look at the positions of the substituents. It is a third carbon atom and fifth carbon atom. 3 plus 5, that becomes equal to 8. So which is the right one now numbering? It is left to right because the lowest sum comes here. Okay, so n number of carbon atoms may be there, however the branches may be there, but when you number it from left to right or right to left, see that the priority should be given in such a way that the sum of the positions of the substituents must be the lowest. Okay, that's what the lowest sum rule. Till now in any exams the rules are not asked. Okay, so only thing you have to understand here, a compound will be given, you have to name it in IUPAC system. Okay, rules are not asked for explanation, but you must understand the rules so that you can easily name any of the given organic compound in IUPAC system. Okay, now there is one more possibility you may ask. Suppose in both the directions the numbering remains the same. Okay, I will write one example like that. Suppose I will write like this, 5 carbon atoms I'll write. Okay, or I may write as 2 carbon atoms and then the positions becomes equivalent. Let me tell you, the 4 carbon atoms are there. Suppose I'll write here one substituent A and here I'll write one substituent B. Okay, now the question you will ask, okay, this is interesting. If you number it from left to right, 1, 2, 3, 4, this is the first carbon atom, second carbon atom, third carbon atom and fourth carbon atom. So positions, if you look at it, is second and third, so we'll add as a 2 plus 3 is equal to 5. Okay, if you number it from left to, right to left, it is first carbon atom, second carbon atom, third carbon atom and fourth carbon atom. Look at the positions, it is second carbon atom and third carbon atom. 2 plus 3 is equal to 5. Now we are in a tension. What to do? Because the second rule says the lowest sum you have to consider. Now the positions of the substituents, if we consider both the cases, we got same. Now we call these positions as equivalent positions. Okay, what do you mean by equivalent positions? You number it from left to right or right to left, the sum of the positions of the substituents remains the same. Okay, now the question you will ask, now which is the right way of numbering? Okay, yaudu agtade? No, nothing like that. Okay, IUPAC rules means you can't take it as a granted. However you number it, it is left to right or right to left only. Any one is possible, but lowest sum rule is not helping us to number it because the sum in both these cases are same. Now remember, okay, in such cases, when there is a equivalent positions, I told you what is equivalent positions. If you add the positions of the substituents from left to right or right to left, if the sum becomes the same, then what you have to do? You have to follow alphabetical order. Okay, now in this case what happens? Suppose if I say this is a substituent starts with the letter A and other substituent letter starts with B, then you have to follow alphabetical order. So first comes A, then comes B, and according to the lowest sum rule here, when equivalent positions the substituents are present, we have to follow alphabetical order. So we have to number from left to right only. Okay, why left to right? Because I just said A and B stands for the two different substituents. Alphabetical order if you follow, it comes first and then comes B, so it should be numbered from left to right. Even though the sum of the positions of the substituents are equal, that means we call them as the equivalent positions, then we follow alphabetical order. Are you clear, students? So that is the second rule. So first rule, longest chain rule, second one, lowest sum rule. Okay, now I think you are clear with that. Let me move on to the third one. that is alphabetical order of the substituents. Alphabetical order, just now I told you, if there is a more than one substituent present, okay, then which is to be given priority. Okay, that is simple, alphabetical order. So try to understand how to follow this particular rule when there is a more than one substituent present. So again, the condition here is, if there is a single substituent present, the rule number 3 is not applicable at all. Okay, only one halogen may be present, or only one alkyl group is present, then no need to follow alphabetical order. So the rule number 3 comes into importance when there is a more than one substituent present. So let me take up one example. See, in this case only, let me write the substituents. Okay, however, the numbering you already understood. Let it be, the lowest sum is not required now. I will write more than one substituent. Okay, say for example, I'll write here chlorine. Somewhere here I'll write bromine. Here I'll write NO2 group. Rest all will be the hydrogen attached to the carbon chain. Okay, so when you look at this example, so what happens here is, if you can't just concentrate only one of the rule, you have to understand all the rules together. Application part is, that is the interesting part. So now when you start naming this in IUPAC system, the first question comes, is it longest chain rule is applicable? No, absolutely no, because you number it in any direction, you will get a 6 carbon atoms. The root word remains hex. Okay, longest chain rule is deciding only the root word. Now, the second thing you have to understand, lowest sum rule, is it applicable? Okay, how you can get it, the lowest sum rule, is it applicable or not? You have to number it. Okay, I won't write now, but you try to understand. It is a second carbon atom. If you number it from left to right, second carbon atom, fourth carbon atom, fifth carbon atoms. Okay, so where the positions are present, it is a second one, is a fourth carbon atom, it is a fifth carbon atom. You will add those positions, 2 plus 4 plus 5. How much? 2 plus 4, 6 plus 5, 11. The sum of the positions of the substituents when you number it from left to right is 2 plus 4 plus 5. Suppose if you number it from right to left, okay, in this direction, this is a second carbon atom, so 2 plus, this is a third carbon atom, 3, 4, this is fifth carbon atom, plus 5. Understood? Second position, third position and fifth position having a substituent. So it is 5 plus 5 becomes 10. 2 plus 3 plus 5, that becomes 10. So second rule is applicable, lowest sum rule. That is, the lowest sum here is a 10. So you must be numbered it from right to left only, not left to right. So this is the first carbon atom, second, third, fourth, fifth and sixth. Okay, now, okay, we understood the first rule, second rule application to that. Now, when you want to say about the substituents, let me tell you what I told you in the last class. If you want to name this now, primary prefix, is it having a cyclic structure? No. Then primary prefix is not there. Secondary prefix stands for the substituents, the different groups. Second carbon atom having a nitro group, third carbon atom having a bromine, fifth carbon atom having chlorine. As a substituents, we call it as nitro, bromo and chloro. Clear? So how you name that group and how you use that as a prefix, there is a small difference. Okay, bromine is an atom or a molecule, as a species we consider, but as a substituent we call it as a bromo, chloro, nitro, like that. Okay, now we have to say nitro, bromo, chloro, no doubt, the second, third and fifth positions having that. Can you say it in any order? No, that's what the third rule. When there is a more than one substituent present attached to the carbon chain, we have to follow alphabetical order. Now try to understand, students, here among chloro, bromo and nitro, which comes first? Alphabetical order, ABCD everybody know. So first comes the bromo, clear? Then after that chloro, then finally nitro. Okay, in any position it may be present. wherever the priority we are not giving according to the alphabetical order, like equivalent positions what I told you already, but here lowest sum rule we applied. But when you want to name this, first you have to say the bromo here, then you say chloro, then you say nitro, irrespective of second carbon atom alli nitro ide, so ಆ position ಗೆ importance ಕೊಡಬೇಕು, nothing like that. We follow alphabetical order that we understood in the lowest sum earlier. But here when you start naming this, it is first comes bromo, means 3 bromo, 5 chloro, 2 nitro, then that is a secondary prefix. Root word is hex. Between the carbon atom there is a single bond, so primary suffix comes n. Okay, I hope you understood that 5 words. If you have not watched the previous video, you will not understand what is a prefix, suffix, root word, what I am telling now. Okay, so it is 3 bromo, 5 chloro, 2 nitro, hexane. Are you clear? So irrespective of the number or the position where the substituent is present, we have to follow alphabetical order. So IUPAC name of this becomes 3 bromo, 5 chloro, 2 nitro, hexane. This is simple about alphabetical order. If more than one substituent is present, then only this is applicable. Okay, if there is only one substituent present, nothing like alphabetical order is followed. So that is a rule number 3. It is very easy. Okay, all the rules are easy. This is very simple. Now, fourth one. Now let me tell you one more interesting thing. Instead of writing the chloro, bromo and nitro, let me write the 2 chlorine atoms only in this case. Same example, I try to modify a little. Okay, now earlier what I told you, 3 bromo, 5 chloro, 2 nitro, hexane. But there is no bromo now, the both came chlorine now. Okay, can we say it as 3 chloro, 5 chloro? No, we won't repeat like that. Instead of that, suppose if the same substituent repeats. See, this rule is also applicable only in some of the compounds, not in all the compounds. If same substituent repeats, then we are again using a prefix. Okay, if only one shift is present, we will not use any prefix. The term mono is used for a single, that we are not using when only one substituent present or only one shift is present. Okay, but if the same substituent repeats for more than one time, then we have to use the term which is called as a prefix. Okay, and what all the prefixes we use? Now in this case 3 and 5, that's 2 different positions having a same substituent. Okay, so how you name it? It is 3, 5. We will mention the position, 3rd and 5th carbon atom. So it is 3, 5. We use a word di, spelling di. Okay, for a prefix like 2, same substituent repeating twice, we use a prefix that di. So it becomes 3, 5 dichloro. Then name continues 2 nitro hexane. Okay, there is no difference with that. But when the same substituent is repeating, we are using the prefix. Okay, so now try to remember, try to understand which all the prefixes used. If only one is there, we are not using mono. If 2 are there, di. If 3 are there, tri. 4 means tetra, penta, hexa, hepta, octa, nona, deca, like that. So from 2 to usually more than 5, 6 is not happening. So you have to remember about di, tri, tetra, penta, hexa and so on. Okay, so that are the prefixes. So I think you understood the rule number 4. If same substituent repeats. Okay, after understanding alphabetical order, remember if the same substituent, I use the word substituent, it may be halogen, it may be nitro group, it may be alkyl group, it may be sometimes a functional group of less importance also. Okay, so it is having less priority, but you have to understand if the same substituent repeats for more than one time, then we follow prefixes. Prefixes like di, tri, tetra, penta, etc. are used if the same substituent repeats. Okay, so that is a rule number 4. Okay, I hope you understood. It is easy. The next rule I'll discuss in the next class, that is if there is a more than one functional group, what happens? That is a polyfunctional derivatives. But before we go to that one, you have to understand these 4 rules exactly. Are you clear? So rule number 1, longest chain rule. I hope you are understanding. We have to number the carbon atoms in the parent chain in such a way that we'll get a maximum number of carbon atoms. Second one, lowest sum rule. You number in the direction in such a way that you add the positions. Okay, when you add the positions, the sum should be lowest. I told you 2-3 examples there, you understood. Rule number 3, if there is a more than one substituent present, we have to follow alphabetical order. Okay, and the fourth one I told you, if same substituent repeats wherever it is present, then we have to use the prefixes like a di, tri, tetra, etc. Okay, so that is easy about the 4 rules. The next rule with the examples I will be taking in the next class. Thank you.